All right, this video is to explain how to graph on a hyperbola. So there's two types of hyperbolas, a horizontal one or a vertical one. And we know it's going to be horizontal when the end over here is +1. It's going to be vertical when it's -1. So a horizontal parabola is going to open left and right and look like this. The point in between here is the center, and these arcs are going to be guided by these asymptotes. And remember that an asymptote is a line that the graph gets very close to but doesn't touch. So to find the center for these graphs, you're going to use the point HK. So notice in the parentheses it has minus H and minus K, so we use the opposite, which we're very used to. And then the slopes of the asymptotes, there's going to be two of them, so it's two slopes. One's positive b over a, and one's negative b over a. Notice in the equation that it's b squared, so to find b or a, you're going to take the square root. On this one, the only thing, there's nothing different. This is h, this is k, this is going to be plus or minus b over a. Now the graph of this obviously is going to look different though. The vertical one looks like this. So we've got the center here, and then the asymptotes will look like this and be our guide for how we draw in the arc. Okay, so let's take a look at this first example. So the center is what is added or subtracted to the x, and there's nothing added or subtracted to the x's in the numerator, so the center is 0, 0. So we're going to start by plotting that point. Then from there, we're going to create a box. And the way we create a box is using the slopes of the asymptotes. So it's going to be the opposite of b over a. So remember, this is b and this is a. Well, this is really b squared and a squared. So the opposite of b is 2, and the I didn't mean to say opposite. The square root of b squared is 2, and the square root of a squared is 3. So you're taking the square root of this number on the right for the b, this number on the left for the a. So now I'm going to use that to graph. Now remember, slope is rise over run, so that's going to control the up and down, and that's going to control the left and right. So starting from the center, we're going to go up 2, and then we're going to go down 2. That's our rise. Starting from this back at the center, we're going to go right 3 and left 3. That's our run. Now we're going to use these points to create a box. And if I go over here and up here, I get a point this way. And over here and up here, I get a point. Over here, I get another point. And here I get another point. So this creates my box. Once I have my box, I can graph the asymptotes. And the asymptotes go through the diagonals. Now I know on some of the graphs, we haven't always graphed the asymptotes, but this one it's really important that we do. Okay? And when you graph it as a dashed line because it means the graph gets really close to it, but it never touches. Over here, because it's positive, it's horizontal, so that means it opens right and left. So you're going to go to the point on your box that's on the right, and here is your graph. It's going to kind of hug that line, get really close to it, but not touched it. These points right here then become your vertices, and to get those points you're just going to read them off the graph. So the first one is going to be 3, 0, and the other one is -3, 0. There is no magic order in which you need to write them, just write both of them. The domain is a little wonky on this one, but we can still figure it out. So starting at the left, with this red line, we do have points out here, so it starts at -infinity. But going to the right, it stops right here at -3, and so we're going to put a bracket. However, there's a gap in the middle, and then it picks back up again and starts back up at 3 and continues on to the right to infinity. And the way we link those two together is with a union or a U. The range measures our y, which is bottom to top, and the graph is going to continue to get wider up and down, so the range is all real numbers. Now, when it's a horizontal hyperbola like this one, the domain is going to be this wonky thing, and the range will be all real numbers. And then when it's a vertical, that will be flip-flopped. So let's look at one of those. So on number 2, your center, there's nothing added or subtracted, so my center is going to be 0, 0. The slopes of my asymptote is going to be plus or minus b over a. Remember, this is my b squared and this is my a squared, so it's going to be plus or minus 4 over 3. So to graph it, the first thing I'm going to do is plot my center. My slope is my rise and my runs, and it's up and to the right, so I'm going to go up 4 and down 4, and then right 3 and left 3, and then I'm going to use those points to create a box. Once I have my box, then I can draw in my asymptotes as dashed lines. And there are my asymptotes. Now I got to figure out where to actually graph the hyperbola. Well, because it's a -1, this one is going to be vertical, so it's going to be up and down. So this time I'll start at the top point and get real close to the line, and the bottom point and get real close to the line. So these 2 points here are now my vertices. So the top one is going to be 0, 4, and the bottom one is going to be 0, -4. This time on the domain, as we go left to right, this keeps getting wider, so my domain is all real numbers. My range, that's the one that's a little wonky, so it starts down below at negative infinity, but then it stops right here at 4. But then it picks up, so I'm going to have a union because it's 2 things, and that's -4, excuse me, and then it starts back up at +4 and keeps on going up to infinity. All right, let's look at number 3. On number 3, the center is the opposite of what's in the parentheses, and this time we have numbers, so it's going to be -5, +3. So let's start at the point -5, +3. The slopes of my asymptotes is going to be plus or minus. The square root of 25 is 5, or the square root of 16 is 4. So this is my rise and run, my rise, so that's my up and down. This is my run, so it's my right or left. So from the center, of the hyperbola, not of the graph, I need to count up 5 and down 5, and then I need to go right and left 4. And now I can use those points to create my box. Once I have the box, then I can graph the asymptotes. Now we need to determine what kind of it is. Well, it's +1, so it's going to be horizontal. And so I'm going to start on the right and left. So it's going to go real close here, real close here, real close here, and real close here. So the vertices are these 2 points, which would be -1, 3, and then the other side would be -9, 3. So the domain, when I go left to right, it starts over out here in negative infinity, but then it stops at -9. And I have a bracket because that point is included, because that is my vertice. That's an actual point there. But then it starts back up again at +9, just kidding, not at +9, at -1, sorry, and continues on to infinity. The range, it expands all the way up and down, so it's negative infinity to infinity. On number 4, my center is +4, -3. So +4, -3 is going to be right here. The slopes of my asymptotes is going to be plus or minus 4 over 5. So from my center, my rise, I'm going to count up 4. 1, 2, 3, 4, and down 4. And my run is right and left, so I'm going to count right 5 and left 5. And then I'm going to use those points to create my box. Once I successfully created the box, then the diagonals will show me where the asymptotes are. Okay, now that I have my asymptotes, now I can decide how to graph it. This is negative, which means it's going to be vertical, which means it's opening up or down. So starting at my top point, there's the top part of my hyperbola, and then at my bottom point, there's the bottom point of my parabola. Okay, the vertices are these 2 points here, which the first one is going to be 4, 1, and the second one is going to be 4, -7. The domain is all real numbers because it stretches all the way left and right, but the range is what gets broken up. So it goes from negative infinity to negative 7, and then there's another section starting at positive 1 and going to infinity. Okay, we're going to skip 5 and 6 and then jump ahead to number 7, just so we can save some time on the video. There's two things that happen here that are important that we should notice. The first one, on the center, we can pretty easily see the y is negative 3. The x is what's added or subtracted to the x, which in this case is 0. So my center on this one is 0, negative 3, which is right here. For the slopes of my asymptotes, it's going to be plus or minus 2 over 2. Now I know we always drill into your head to reduce, but this is a time where you don't reduce, because otherwise it's not going to make your box correctly. So here's my rise and my run, so I'm going to go up 2 and down 2 for my rise, and right 2 and left 2 for my run, and then use those to create my box. Once I have created the box, then I'm going to draw in the asymptotes, going from one diagonal to another. And notice I'm drawing them as dashed lines. Now let's figure out, it's positive 1, so it's going to be horizontal. So I'm going to start on my right point, my left side. The vertices on the right would be 2, negative 3. And the one on the left would be negative 2, negative 3. The domain, when I go left to right, the domain gets broken up because I've got this empty spot in the center. So it's going to go from negative infinity to negative 2. And then there's another section that starts at positive 2 and continues on to infinity. But for the range, it expands up and down, so it's negative infinity to infinity. And that's how we graph a hyperbola.